This chart illustrates the defining financial paradox of 2026. On one axis, we see hyperscalers on track to spend $675 billion on AI infrastructure this year. On the other axis, we see the measurable profit and loss impact on the enterprises actually buying that technology. It is completely flat. The data behind this flat line is stark. According to the Rand Corporation, over 80% of corporate AI projects fail to deliver their intended value. And a 2025 study from MIT found that 95% of organizations see zero measurable P&L return from their generative AI pilots. The immediate consequence is a sharp spike in corporate retreat. S&P Global reports that 42% of companies abandoned most of their AI initiatives entirely in 2025, up from just 17% a year prior. The instinct across boards and executive teams is to blame the foundation models, assuming the technology itself is overhyped or undercooked. But the models are performing exactly as designed. A 95% failure rate points to an architectural problem, not a technological one. Enterprises are purchasing models without building the necessary infrastructure required to capture, direct, and measure their value. The result is pilot purgatory. This is the organizational graveyard where initial AI experiments succeed in a sandbox, but abruptly stall and die before production. Escaping this purgatory requires a foundation most companies skip entirely: the measurement layer. If an enterprise cannot mathematically prove a specific AI task is working, it cannot scale it. This diagram shows the three-layer architectural framework required to move AI into recurring operations. It starts with measurement to prove the task works. On top of that sits infrastructure to connect those tasks into automated workflows. And finally, strategy to ensure the entire system continually learns and compounds its advantage. Attempting to deploy an AI strategy or build scaling infrastructure without first securing the measurement layer at the base is the direct structural cause of zero ROI outcomes. To understand why the measurement layer fails, we have to look past public press releases and examine the rigid financial truth required by regulatory filings. Most enterprises operate on the headcount fallacy. This is the executive assumption that deploying AI allows a company to fire staff, and the resulting salary savings can be logged as the return on investment. In practice, companies rarely reduce their headcount after deploying AI. Instead, they absorb natural attrition, redeploy staff, or slow their hiring rate. This makes full-time equivalence avoided a modeled counterfactual. It relies on assumptions about hiring that never actually happened. We can see this disconnect clearly in the financial sector. Over the last few quarters, major U.S. banks took to their earnings calls to claim massive developer productivity gains, consistently citing 10 to 20% improvements driven by AI tools. This side-by-side comparison shows the reality buried in their SEC filings. During the exact period banks claimed double-digit productivity savings, actual compensation expenses grew by billions. Modeled capacity avoidance never hits the income statement. If payroll goes up, the business case collapses under audit. Relying on theoretical headcount reductions instead of realized financial outcomes guarantees that the initiative will eventually be perceived as a failure. Replacing the headcount fallacy requires a rigorous alternative. The 5% of companies actually extracting value at scale use a 7-step value model. The critical requirement of this model happens at step 1, defining specific, countable baseline metrics before the AI touches any enterprise data. You cannot measure improvement if you don't know the exact cost of the existing process. XPO Logistics provides one of the clearest examples of this model operating in a production environment. XPO handles roughly $900 million in transported freight costs. Before deploying AI, they defined rigid deterministic metrics for their entire fleet: the specific number of line haul freight diversions, and the exact volume of empty miles driven. This flowchart tracks how real-time AI routing feeds directly into their financial attribution model. They trace an 80% reduction in line haul diversions down to the dollar, calculating $29 million saved per efficiency point. This works because the framework is built directly into the workflow. Contrast this native integration with the standard enterprise approach: launching an AI pilot, realizing months later that no baseline was captured, and trying to bolt a reporting dashboard onto the back end to hunt for efficiency metrics. Genuine ROI is not a byproduct discovered after a project finishes. It is an engineering requirement that must be built into the workflow before a single dollar of budget is approved. Once you have a measurement model that proves a specific task works, you need to scale it. That requires the second stage of the stack, the infrastructure layer. The primary barrier to enterprise scaling is data fragmentation. COBOL-based mainframes, fragmented acquisitions, and legacy data architectures create environments where AI models simply cannot access the information they need to function reliably. This routing map illustrates the core infrastructure challenge. Large language models are probabilistic, interpreting text. Financial calculations are deterministic, requiring exact math. Palantir solves this with an ontology layer, routing hard calculations to structured code. Laggards let the LLM attempt math directly, generating hallucinated numbers. Failing to architecturally separate probabilistic interpretation from deterministic calculation destroys user trust instantly and fatally stalls adoption across the enterprise. The way an enterprise chooses to purchase its infrastructure directly dictates whether it can close this measurement gap. Horizontal delivery models like Snowflake or Databricks provide excellent governed data layers. However, horizontal platforms supply raw infrastructure without workflow configuration. This pushes the entire burden of proving ROI onto the client. Their native metrics they provide are consumption-based: tokens processed, API calls, active seats. They measure how much compute you bought, not the quality of the decisions it produced. The alternative is utilizing domain-specific, vertical agentic workflows. These are turnkey applications designed exclusively for highly specialized tasks, like legal contract review or private equity due diligence. Because the workflow is incredibly narrow, attribution happens natively. When a lawyer uses a domain-specific agent to review a contract, the platform tracks exactly which clauses were flagged, which were revised, and how much time was logged on that specific document. Closing the ROI gap requires this level of integration. AI must be embedded deeply enough into a specific business process that the daily act of using it automatically generates the evidence that it works. Infrastructure layers allow an organization to automate. The final layer, strategy, determines whether that automation simply runs an old process faster or actually compounds an enterprise advantage over time. This diagram illustrates the standard AI strategy, the data cycle. Increased usage generates training data, improving the model. But to scale, it needs a second loop, the adoption cycle. Easier workflows create internal champions who advocate for expansion, feeding more users into the compounding cycle. Without both cycles running simultaneously, adoption flatlines. The model might get smarter in isolation, but the organization will lack the momentum to scale it, dragging the initiative back into pilot purgatory. The capital markets are no longer waiting for companies to figure this out. They are already pricing this architectural maturity into equity and debt. The Terminal Acts repricing matrix maps internal infrastructure maturity against measurement rigor. Dual leaders, scoring high on both, posted a 1,200 basis point outperformance over 12 months. Meanwhile, laggards face a 30 basis point credit spread penalty for spending without verifiable returns. Financial analysts estimate that the window to close this execution gap is closing. Within 3 to 5 years, the performance divide between the leaders and the laggards will calcify into a permanent structural disadvantage. Escaping the 95% failure rate requires strict operational discipline. Refuse to approve without quantified metrics. Separate probabilistic models from deterministic data. Build measurement directly into the workflow. The choice for enterprise leadership is no longer whether to buy AI. The choice is whether to build the architecture required to prove it works or face the permanent market penalty for spending blindly.